pumpkin pie is more than a dessert. It's a taste of history on the Thanksgiving table. Its story stretches back to the very first harvest feasts, a direct descendant of the early colonists' struggle and survival. Today, that legacy is produced on an epic scale. Inside sprawling factories, 100-meter ovens and massive mixers work tirelessly to fulfill a national tradition, turning millions of humble pumpkins into the iconic spiced filling. Pumpkin pie has been part of American history for centuries. Early settlers in the 1600s baked pumpkins filled with milk, honey, and spices over open fires. By the 1800s, cooks began turning that mixture into the creamy pie we know today, flavored with cinnamon, ginger, and nutmeg. In 1929, Libby's introduced canned pumpkin puree, allowing families to make pies faster and easier than ever before. From small-town kitchens to large factories, the recipe changed little, but the scale exploded. What started as a homemade dessert has become a national symbol of comfort. So how do modern factories create millions of pumpkin pies with perfect texture and flavor? Production begins with thousands of pumpkins harvested from farms across Illinois. The state that grows about 85% of all processed pumpkins in the U.S. Conveyor belts carry the bright orange squash into large washing tunnels, where jets of water under 100 psi remove dirt and stems. High-speed blades, spinning at 1,200 revolutions per minute, slice each pumpkin in half before it moves to a steam cooker. Inside, pressurized heat of 240 degrees Fahrenheit softens the flesh in just 90 seconds. The cooked pieces are then scraped and fed into stainless steel grinders that turn them into smooth, golden puree. Each batch is tested for moisture, color, and sugar content to make sure it will bake evenly later. The sweet aroma of cooked pumpkin already fills the room. But how does this puree turn into the creamy filling we know? The next stage takes place inside massive stainless steel tanks that hold up to 5,000 gallons of pumpkin puree. Automated dispensers add sugar, milk, and liquid eggs with pinpoint accuracy. Then, cinnamon, nutmeg, ginger, and cloves are added by weight to create the familiar holiday flavor. Mechanical paddles churn the mixture at 40 rotations per minute, blending everything into a silky texture. Sensors constantly check the temperature and viscosity to ensure consistency across every batch. The smell of spice and sweetness fills the factory air as thick streams of orange filling flow through insulated pipes to the next station. Here, it will meet the other essential half of the pie, the crust. The crust begins with flour, shortening, and cold water mixed inside a 300-gallon planetary mixer. The dough forms into a smooth, elastic mass before being fed into heavy rollers that flatten it to exactly 3 millimeters thick. A rotating cutter stamps out perfect circles of dough, hundreds every minute, while mechanical arms lift each one into aluminum pie tins. The edges are crimped automatically by pressing rings that imitate a hand-fluted pattern. Chilled air keeps the dough firm and prevents melting before baking. Every crust is checked by camera sensors for cracks or uneven thickness. It's hard to imagine, but each crust you see in stores started on a machine like this. Can you guess how fast these pies move once the filling is poured? At the filling station, robotic nozzles dispense 150 milliliters of pumpkin mixture into every crust. The pies move along a conveyor that leads directly into a continuous tunnel oven, stretching 100 feet long. Inside, heat stays steady at 375 degrees Fahrenheit, while high-powered fans circulate air for even baking. As the pies travel for 25 minutes, their surfaces darken slightly, and the edges turn golden. The scent of caramelized sugar mixes with nutmeg and cinnamon as the filling sets into its custard-like texture. Quality control cameras scan each pie for color and uniformity, ensuring the batch meets commercial standards. When the trays roll out, the factory smells like a Thanksgiving kitchen multiplied by 1,000. But the pies aren't ready to pack yet. They still need to cool down safely. Freshly baked pies enter a long cooling tunnel where 40 degrees Fahrenheit air circulates through giant fans. The cooling process lasts about 15 minutes, bringing the temperature low enough to stop cooking but high enough to avoid condensation. Laser scanners check each pie's height and diameter, while robotic arms remove any that fall outside tolerance. The remaining pies are wrapped in airtight plastic, sealed with nitrogen to extend shelf life up to 60 days. Labels are applied, barcodes scanned, and boxes stacked onto pallets heading for refrigerated trucks. Within 24 hours, these pies will appear in supermarkets nationwide. From field to factory to table, each one carries the same promise: a slice of warmth and memory on every Thanksgiving plate. According to the National Retail Federation, Americans spend over $3.6 billion each year on Halloween treats, and a surprising part of that goes to ice cream. It may sound odd, but even in the chilly air of October, ice cream becomes a centerpiece of celebration. Inside massive factories, thousands of gallons of orange and black ice cream swirl through stainless steel pipes chilled to minus 30 degrees Fahrenheit. Pumps, mixers, and freezing drums run day and night to create a dessert that looks spooky but melts perfectly on the tongue. The air smells like pumpkin spice and vanilla, while robotic arms drop tiny ghost-shaped candies into every batch. What seems like a simple scoop hides an incredible amount of precision, timing, and science. So how does a frozen treat turn into a Halloween icon every October? Today, we'll step inside the chilling world of Halloween ice cream. Halloween ice cream first appeared in American stores during the 1950s, when companies like Breyers and Baskin-Robbins began releasing seasonal flavors. These early versions were simple: vanilla ice cream dyed orange, with streaks of chocolate or fudge to match Halloween colors. As the holiday grew into a cultural event, manufacturers added pumpkin puree, caramel swirls, and candy pieces shaped like ghosts and bats. The trend turned ice cream from a summer snack into a fall celebration. Every October, supermarket freezers fill with black and orange tubs, each one blending nostalgia and novelty. But how do factories turn milk, sugar, and color into this chilling treat for Halloween night? Every batch of Halloween ice cream starts with a simple mix of milk, cream, and sugar. Stainless steel tanks, each holding up to 2,000 gallons, are filled automatically by pumps connected to refrigerated storage silos. The ingredients are carefully measured using digital scales and flow meters to ensure every blend is identical. Once inside the tank, large mechanical paddles stir the mixture to prevent fat from separating. The mix is then pasteurized at 160 degrees Fahrenheit for 30 seconds, a temperature high enough to kill bacteria, but gentle enough to preserve flavor. From there, chilled water coils drop the temperature back down to 40 degrees Fahrenheit in less than 2 minutes. This rapid cooling locks in freshness and stops bacteria from returning. At this stage, stabilizers and emulsifiers are added to keep the ice cream smooth, even after months in deep freeze. Operators take small samples to test butterfat, pH, and texture before approving the mix for the next step. The result is a thick, creamy liquid base that looks like melted vanilla milkshake. Its mild sweetness fills the air, signaling the beginning of the Halloween transformation. But how does this pale liquid soon become streaked with orange and black? The neutral base is now divided into several blending tanks, each assigned a different flavor. In one, workers add pumpkin puree, cinnamon, nutmeg, and clove to create the classic autumn taste. In another, cocoa powder and chocolate syrup produce a dark, rich base. A third tank receives vanilla extract for contrast. Each batch is mixed at 40 rotations per minute by mechanical paddles that keep air from forming bubbles. Optical sensors measure the hue of every tank to maintain perfect Halloween tones: bright orange for pumpkin, deep black for chocolate, and snow white for vanilla. Food scientists monitor the mixture's temperature, keeping it steady at 38 degrees Fahrenheit, so flavors stay balanced and do not separate. Automated pumps transfer the mixtures into insulated holding pipes that run across the production floor. The smell is sweet and spicy, filling the room with a reminder of October fairs and caramel apples. Everything now depends on the next stage, where cold temperatures and spinning blades will freeze these colors together into a swirling masterpiece. Inside the freezing room, the temperature drops to minus 30 degrees Fahrenheit. The colorful mixtures are fed into continuous freezers, giant horizontal cylinders lined with cooling jackets. Metal blades scrape the walls constantly, preventing ice from building up. As the liquid flows through, it partially freezes while air is injected under pressure to make the texture light. The ratio of air to ice cream, known as overrun, is precisely controlled at 100%, meaning half the final volume is tiny air bubbles. This gives ice cream its soft, scoopable consistency. Multiple nozzles inject the orange, black, and white mixtures into the same chamber, twisting them together in slow, mesmerizing spirals. Each swirl forms a different pattern, depending on flow rate and viscosity. Conveyor belts carry containers beneath the filling spouts, where sensors time the release to create perfect layers. The rhythmic hum of compressors and the hiss of cold vapor fill the air. Every tub that leaves the freezer has a one-of-a-kind marble pattern. Have you ever wondered how ice cream can hold its creamy form even as it begins to melt? The answer lies in what happens next. Precision freezing and decoration. The freshly frozen mixture now has the consistency of soft serve. It travels through steel pipes into forming machines that portion exact amounts into tubs or molds. Some factories shape the ice cream into bars, while others fill family-sized containers. Robotic arms drop toppings like ghost-shaped candies, cookie crumbs, caramel ribbons, and candy eyes in timed bursts. The line moves fast, nearly 200 containers every minute, so every second counts. To keep decorations from sinking, the surface is instantly flash frozen using a fine mist of liquid nitrogen at -320 degrees Fahrenheit. Within seconds, a thin layer of frost forms, sealing the design in place. Quality control cameras zoom in to check each container, ensuring the swirl pattern and topping ratio are uniform. A single defect can stop the entire line. The contrast of bright orange and deep black gives the product its spooky appeal, while the faint smell of chocolate and spice lingers in the cold air. But even now, the ice cream is still fragile. It must be hardened quickly before it's ready for storage. How do factories lock in that texture for months without ice crystals forming? To complete the process, the ice cream travels through a massive hardening tunnel that stretches the length of a warehouse. Powerful fans circulate air at -40 degrees Fahrenheit, freezing every pint solid in just 15 minutes. The frozen tubs emerge stiff as stone, ready for packaging. Automated packers wrap each one in moisture-proof film and seal it using nitrogen gas to push out oxygen. This prevents freezer burn and keeps the ice cream fresh for up to 6 months. Labels and expiration dates are printed by laser. Then, robotic arms stack the tubs into cardboard boxes. Pallets loaded with thousands of units are moved by forklifts into cold storage rooms, each maintained at -20 degrees Fahrenheit. From there, trucks with temperature-controlled trailers carry them to supermarkets across the country. Every hour, a single production line can complete more than 100,000 servings of Halloween ice cream, each identical in color, flavor, and texture. The journey from fresh milk to frozen art takes less than 6 hours. And behind every bite lies the hum of machines, the chill of nitrogen, and the creativity that turns October into America's sweetest season. According to the National Confectioners Association, Americans consume more than 17 billion quarts of popcorn every year, enough to fill over 45 billion gallon-sized buckets. but a small share of that popcorn takes on a different life each Halloween. Inside giant steel drums, sugar syrup boils to 230 degrees Fahrenheit. Hot air blasts reach 400 degrees Fahrenheit, and robotic presses shape thousands of sticky golden spheres known as popcorn balls. The air smells like caramel and butter, and every crunch carries the nostalgia of trick-or-treat nights decades ago. What once began as a homemade treat in small-town kitchens is now produced on industrial lines that run almost non-stop each fall. But how do millions of popped kernels stick together perfectly without burning or collapsing? Today, we step inside the machines that turn ordinary popcorn into one of America's sweetest Halloween traditions. Popcorn balls first appeared in the late 1800s, when families in the American Midwest mixed popped corn with molasses or honey to make simple, affordable snacks. During the Great Depression, they became a homemade favorite because ingredients like sugar and corn syrup were cheap and easy to find. By the 1950s, when Halloween turned into a national celebration, popcorn balls became one of the most popular homemade treats given to trick-or-treaters. They carried the warmth of small towns and community gatherings. Today, industrial machines recreate that same flavor and texture at massive scale. But how do factories shape thousands of perfect popcorn balls every hour without crushing a single kernel? The process starts with tons of special popcorn kernels, chosen for their ideal moisture level of 13 to 14%. Trucks unload them into silos connected to stainless steel popping kettles. Each kettle holds hundreds of pounds of kernels and heats them with pressurized air reaching 400 degrees Fahrenheit. Within seconds, the quiet room erupts with the rapid crack of explosions as the kernels burst open, expanding up to 40 times their original size. A vibrating separator filters out the few unpopped kernels, while strong air jets cool the fresh popcorn instantly to prevent sogginess. The result is a mountain of light, crisp popcorn that stays dry and fluffy. Operators test small samples for expansion rate, density, and moisture to make sure every batch meets factory standards. The smell of warm corn fills the air, a scent both industrial and nostalgic. Once cooled, the popcorn travels through enclosed conveyors toward the mixing area, where it will meet a river of molten sweetness. But how do factories make that shiny caramel coating that holds every piece together so perfectly? The syrup is the heart of every popcorn ball. In large, steam-jacketed kettles that hold 300 gallons, a mix of sugar, corn syrup, water, and butter is blended by heavy-duty paddles spinning at 60 revolutions per minute. The The mixture heats gradually until it reaches 230 degrees Fahrenheit, the stage confectioners call softball. Digital thermometers and viscosity sensors monitor the process constantly. If the temperature rises too high, the sugar burns and turns bitter. Too low, and the syrup stays thin and won't hold the popcorn together. After about 20 minutes, the liquid thickens into a smooth, amber-colored caramel. Steam rises in waves, and the sweet smell spreads through the entire factory. A pump transfers the syrup through insulated pipes toward the coating drums, keeping it hot so it doesn't crystallize. In some factories, a touch of vanilla or honey is added to create signature flavors. The timing must be perfect. Once the syrup reaches the popcorn, there is only a small window to coat it evenly before it hardens. So how do they spread the syrup without melting or crushing the delicate popcorn? Fresh popcorn pours into giant rotating drums made of polished stainless steel. Each drum is 7 feet wide and can hold 300 pounds of popcorn. As the drum turns slowly, thin streams of hot syrup spray across the tumbling popcorn from nozzles arranged above. Every rotation helps the syrup cover each piece evenly, transforming the plain white popcorn into golden, glossy clusters. Air nozzles blow cool air at 60 degrees Fahrenheit to control how fast the syrup sets, keeping it sticky enough to bind, but not so wet that it clumps. Sensors inside the drum monitor humidity and temperature in real time, while technicians adjust airflow for perfect consistency. In seasonal runs, orange coloring and a hint of pumpkin spice are added for Halloween batches. After several minutes, the popcorn emerges glistening and fragrant, coated in a thin shell of caramel. The sound of the tumbling popcorn and the scent of warm sugar make this the most satisfying stage to watch. Interactive question: have you ever wondered how these pieces manage to hold their round shape instead of breaking apart? The secret lies in the precise mechanical pressure used in the next step. The coated popcorn moves down conveyors into automatic forming machines. Each portion drops into a circular mold where hydraulic arms press from both sides to shape it into a perfect sphere. The molds are heated to 110 degrees Fahrenheit to keep the caramel pliable during pressing. The pressure, about 50 pounds per square inch, must be exact, strong enough to compress the popcorn without crushing it. Every minute, a single machine can mold over 150 popcorn balls, each weighing about 3 ounces. Brushes gently rotate over the surface to polish the caramel and remove loose flakes. Fans then blow cool air at 45 degrees Fahrenheit, hardening the caramel while maintaining the soft crunch inside. The rows of freshly shaped popcorn balls roll down the line, their glossy shells catching the light like golden marbles. Workers visually inspect them for cracks or deformities before they continue. The process is fast, rhythmic, and mesmerizing to watch. But even with perfect shape and color, these treats must be cooled and sealed quickly to preserve their texture. What happens next determines how long they stay fresh and crisp. Once formed, the popcorn balls enter a long cooling tunnel chilled to 40 degrees Fahrenheit, where powerful fans circulate dry air to draw out heat evenly. This cooling stage lasts about 10 minutes and locks the caramel into a firm shell while keeping the popcorn inside tender. Laser sensors scan every ball for uniform size and weight, automatically removing any that don't meet specifications. The approved ones travel to the wrapping station, where robotic arms lift and seal each one in airtight plastic in just half a second. Nitrogen gas is injected into each pack to prevent moisture buildup and extend shelf life up to 6 months. Labels are printed with flavor, date, and batch code before mechanical stackers load the packs into cartons. From the smooth swirl of Halloween ice cream to the sticky sweetness of popcorn balls and the golden layers of a pumpkin pie, every factory tells a story of precision, patience, and nostalgia. These are more than seasonal treats. They are snapshots of American tradition, built by machines but born from memory. Behind every bite lies the hum of stainless steel mixers, the hiss of steam at 230 degrees Fahrenheit, and the rhythm of conveyor belts that never rest. What feels like a simple dessert in our hands is the result of chemistry, engineering, and decades of craftsmanship working together in perfect sync. In a world that moves faster every year, these factories preserve something deeply human: the joy of sharing food that reminds us of childhood, family, and home. Whether it's a warm pumpkin pie on Thanksgiving, a scoop of spooky ice cream in October, or a crunchy popcorn ball during trick-or-treat, each one connects us to moments that never fade. So next time you see these familiar treats in your freezer or on a store shelf, take a second to imagine the journey behind them: the roaring heat, the freezing chill, the endless precision that keeps every batch identical. It's not just food, it's a celebration of time, technology, and tradition combined. If you enjoy discovering how everyday products are made, don't forget to subscribe to Captain Discovery. Join us as we travel deeper into the world of modern manufacturing, uncovering the secrets behind the foods, machines, and materials that shape our lives. There's a whole world hidden behind every label, and we're here to open the door.